Okay, so as we pick up where we left off yesterday, we were working on the second and third learning target. I can describe the relationship between potential and kinetic energy, and I can compare the kinetic and potential energy of different objects at varying positions. So as we work through that, you started to work on calculating kinetic energy. Today, what do you think we're going to learn how to calculate? Potential energy. And so we can see the relationship between the two eventually. So as you look at your notes, we're now on the back side of your notes. We talked about two types of potential energy yesterday. What was the first type of potential energy that we talked about? Cody, what was it? Elastic potential energy. And what was the second type of potential energy that we talked about, Eli? Chemical potential energy. Bless you. Okay? All right. So the third type we're going to talk about is electric potential energy. So number 3. Is electric potential energy. And so that is what stores most of our electricity to communities. It can be collected in lots of different ways, whether it's, windmills. How many of you have seen windmills before? Okay, so that's a way that they store that electric potential energy, and that provides power to different communities. I think about on the way to Chicago, there's a huge windmill farm. Okay, and all of those windmills, if you've ever driven to Chicago, all of those windmills supply electricity for that whole entire community. Okay? Sorry, Noah. Okay? No, we used to take a field trip to Chicago. It's called Night at the Museum. So I miss it too. This is the first year, and I think we figured it out last year. I'd gone 7 years. Okay, so this is the first year in 7 years we're not going. Okay? Some of the field trip policies and stuff have changed. So, okay. All right. Back on track. As we look at number 4, and number 4, the next type of potential energy is going to be gravitational potential energy. All right, so potential energy is related to the object's height above the ground. It doesn't only depend on height, but that's one of the things that it depends on. What else do you remember from your workbook pages? What else does potential energy depend on? Sydney? Mass. Okay, so we've got height, we've got mass. And the other thing, I went a little too far ahead here. Okay? The other thing that it depends on is gravity. So as you fill in your notes there, it depends on mass, height, and acceleration due to gravity. Okay? So when we fill in our formula and we talk about our formula, we're actually going to write two things. Okay? Gravitational potential energy equals height times mass times gravity. And Kelly, I think you asked a question about weight yesterday. Okay? So when we talk about mass times gravity is what equals weight. Okay, and so that's why when you see that word so loosely used, okay, weight and mass are directly related. Are they the same thing? No. Okay? Mass times gravity is what equals weight. So really, and out to the side for your purpose in the 7th grade, You need to know that gravitational potential energy equals height times what?
Mass.
Not mass, weight. Okay.
Doesn't it say mass on that one?
What was that, Noah?
It says mass right there, though.
Yeah. It says height times mass times gravity. So this mass times gravity essentially equals weight. Okay? That's the same thing as weight.
So if we could just do height times weight.
That's why we wrote this formula too. And this is what I want you to have written as well. Okay? Riley.
What's the difference between chemical potential energy and chemical energy?
Okay? Chemical energy is energy that's actually being used. Okay? Potential kinetic or chemical energy is energy that's being stored. Okay? So if you're sitting there and you're looking at your car and it's not moving, it's not running, that's chemical potential energy. The minute you turn that car on and you start it running, that's when it becomes that chemical energy that eventually converts into thermal energy and kinetic energy. Okay? That's what you just filled in. Yep. Okay, so let's look at your example number 1 in your notes. A box weighs 40 newtons and is at a height of 1.5 meters. Do we know the weight?
Yes.
Okay, do we know the height?
Yes.
All right, so all we're going to do to find the gravitational potential energy is we are going to multiply 40 times 1.5. 40 times 1.5. All right, 40 times 1.5 is what, Jalen? 60. Do we agree with Jalen? Those of you that had your calculator, double check. 60 what? We're talking about energy, and energy is measured in joules. Okay?
So the meters and newtons don't matter?
Okay, well, the meters and newtons do matter. Okay? When I talked to you before, and we talked before about joules, I told you that joules is the same thing as newtons per second. Or I'm sorry, newtons per meter. There. So we're making that connection that they are the same thing. Okay. Now I want to back up briefly and talk about mass and gravity. Okay? Does anybody know what the rate of gravity is here? Okay. All right. Things fall at 9.8 meters per second. Okay. Have you heard that before, that number, 9.8 meters per second? Okay. All right. So that's the rate at which gravity affects objects. Here, right now. So if I'm holding 2 objects, it doesn't matter what I'm holding. If I'm holding this popsicle stick and this Sharpie, now which one probably has more of a mass? The Sharpie. Okay, if I hold them at the same height, they're both going to fall at the same rate. Which one do you think will hit the ground first? Okay, so your natural instinct is to say, because the Sharpie has more mass, okay, your natural instinct is to say the Sharpie. Okay? But because they both fall at the same rate and gravity is the same, are they at the same height? Okay? What do you notice, Abby?
They both drop to the ground at the same time.
Okay? They both hit the ground at the same time. Now, if we went to the moon, okay, if we were to drop them and they were to hit the ground, again, the gravity is the same on the moon. So it doesn't not the same here. They might take a little bit longer to hit the surface. Okay? But they still should drop it the same. Okay? Alright, so that's just a discussion about gravity as we go from there. Riley, did you have a question?
Wouldn't it be different though if you use a feather?
Okay, so then we get into a feather, and what comes into play with a feather? Okay, you've got your air resistance. Okay, that does cause in that friction that will cause that to drop a little bit slower because it's catching on that. Jalen, what's your question?
So if you're on the moon, and so doesn't the moon's gravity make like
Worked. Some of you have worked on your example. So let's look at example 2. All right, so example 2. A child weighing 200 newtons. Now 200 newtons is your mass and your gravity combined. So that's what your weight. Stands on a wall that's 1.2 meters high. How much potential energy does the child have? So what are we going to do to figure out the potential energy?
Multiply.
Multiply what by what?
240?
Okay, we're going to multiply 200 times 1.2. So write it out on your paper for me so you've got examples. All right, what do we got? 200 times 1.2 is what, Carly?
240 joules.
240 joules. Do you agree with Carly? All right. We got a challenge problem. It's like yesterday. Okay, somebody read for me the challenge problem. All right, Abby, go ahead. Read the challenge problem.
A book is on a shelf that is 2 meters above the ground. The book has 12 joules of potential energy. How much does the book weigh?
All right. So we know the gravitational potential energy, don't we? Don't we?
Yes.
All right, so when we plug that in, so we're setting up our formula a little different. Okay, so we've got 12 joules over here. Do we know the height? Do we know the height? Yes. Do we know the weight? Do we know the weight?
Oh no.
No.
I do.
All right, so I've got it set up. 12 joules equals 2 times the weight. So what are we going to have to do, my algebra whizzes? Okay, what are we going to have to do? All right, Jalen, what you got?
Got divide.
You got to divide both sides by 2. All right, so what is the weight of this book? 6 newtons. Thank you for using your units. That one was a little bit easier than yesterday's challenge problem, wasn't it? Okay. All right, again, when we're talking test-wise, focus on example 1 and example 2. Okay, you need to be able to figure out the gravitational potential energy.
Are you going to use a
All right.
calculator on the test?
Yes, I will allow you to use the calculator on the test. All right, you got your clickers? Let's test your knowledge here. Let's see how you are. All right, looking at the pictures. If the trees have the same mass, which has the greatest potential energy? If the trees have the same mass, which has the greatest potential energy? You don't have to hit the silver button. You just have to hit A or B. So A is the tree on the highest cliff, or B is the tree on the lower cliff.
Is it supposed to come up with 1 or 2?
Yeah, it might come up with a 1 or a 2 instead of the letters.
Mine's not working.
Again?
Again.
All right, no, for just today, go grab another one. Okay? I can't win with this clicker. All right. All right, Noah, answer real quick. All right, I got 31 in here, so let's see how you did. All right, 94% of you said A, good. Why is A the correct answer, Kylie? Because it's at a higher distance. All right, let's look at the next one. It's real. Okay. All right, you got to do some math here. So all you're doing is hitting the number. Okay. A rock that weighs 2.4 newtons sits on the edge of a cliff that is 30 meters high. What is the rock's potential energy? So you got to do some math. You got to know the formula. If you got a calculator, share it with your neighbor, please, if they need it. What's the formula that you have to know for this? Gravitational potential energy equals what? What, Olivia?
Weight.
Weight times height. All right, looks like I'm waiting on two more of you. One more of you. Not on this. I mean, I can pull it up, yes. All right, ready?
Yeah.
All right, final answers. Let's see how you did. All right, good. 97% of you said C, 72 joules. 97% of you are correct. Okay, remember on this one, you are using height times weight. Let's look at the next question. All right, blank energy is defined as stored energy. Which energy is defined as stored energy?
Have you ever dropped your iPad?
Fortunately, no, Noah. I've not dropped the iPad.
Oh, she's on record.
All right, I'm waiting on four more of you.
So 3%.
I need final answers in 5, 4, 3, 2, 1. All right, good. 94% of you said potential. For the one person that said kinetic, what's kinetic? Energy of motion. Have we talked about contained energy? No. Okay. All right, next question. A small car is traveling at a speed of 60 miles per hour on the highway. In the next lane, a large passenger bus is traveling at the same exact speed. Which of the following is true? A, the car and the bus have potential energy but not kinetic. B, the bus has more kinetic energy than the car. C, the car has more kinetic energy than the bus. Or D, the car and bus have the same amount of kinetic energy. All right, I need final answers in 5, 4, 3, 2, and 1. All right, let's talk about this one. We're half and half. The correct answer is B. Okay? All right, so obviously we have a discrepancy here, so let's talk this out. Let's go back to your kinetic energy notes. What affects kinetic energy, Cody? The mass and what else? Mass and what else? Eli? Velocity. Okay, in this case we know that they're going the same velocity, the same speed. What do you know about a small car and a big bus? The bus is bigger, it has more mass, and in turn, if they're going at the same speed, then the bus has more kinetic energy. All right, so we'll explore that one a little bit more. All right, next question. From the list below, select the type of potential energy that allows you to throw a ball. From the list below, select the type of potential energy that allows you to throw a ball. Ooh, I'm hearing some conversation that might be good. Think about what allows you, ultimately, what allows you to throw a ball. Discuss it with your neighbor if you haven't. Tell them what you think it is. You have the opportunity to change your answer if you need to. Let me hear reasoning. Don't just tell them what you think the answer is. Explain why you think it's the answer. All right, final answers in 5, 4. Change them if you need to. 3, 2, 1. Could you eliminate one, Riley? Human potential energy we can eliminate. Hopefully. All right. Let's talk about this. We still weren't quite agreeing. Where do you get your energy from? From food. Okay? You get your energy from food, which is what type of energy? Okay? So that's why chemical potential energy. Okay? Okay, the key is allows you to throw a ball. Okay? If we said what allowed the ball to fall, that would be gravitational potential energy. Okay? But the key is finding the energy. All right. A stone is held above the ground. When the stone is dropped, blank energy is converted to blank energy. So let's fill in the blanks. A would say when the stone is dropped, kinetic energy is converted to potential energy. B would say when the stone is dropped, mechanical energy is converted to electrical energy. C would say when the stone is dropped, potential energy is converted to kinetic energy. And D, when the stone is dropped, chemical energy is converted to electrical energy. I need final answers, and I'm waiting on one more person. 3, 2, 1. Somebody's missing out. There we go. All right, good. 81% of you said potential to kinetic. Okay? All right. Got another question on the board. Position A is the starting point of the roller coaster. At which position will the roller coaster have the most kinetic energy? Think about it. This one might be tough too. Where would it have the most potential or most kinetic energy, excuse me? At point A, B, C, or D? I need final answers in 3, 2, 1. Somebody's missing out. All right, there we go. All right. The correct answer is C. Okay? At point C, listen. At point C, this is where the roller coaster is going the fastest. Okay? And we're going to explore roller coasters a little bit more tomorrow. Okay? Right before it starts to slow down, and it will start to slow down once it gets to D. But we got to talk about where it's going the absolute fastest. And it would be going the fastest at C. All right. So as we wrap up our 2 learning targets, I'm going to give you an exit slip to see if you can show me what you know. I want you working independently. Our 4th learning target is on the board. We will probably get to our 4th learning target after fall break. We're going to continue to work with potential and kinetic this week. Okay?